Alright, so here we're going to have a look at question 11. Now this question is from the Advanced Maths 2020 HSC paper. Advanced Math 2020. This is the first non-multiple choice questions. So multiple choice questions at the beginning are usually a mix of various different topics. Some of them are easy, some of them are hard, some of them can be very, very easy. The longer answer questions, which is usually question 11 and onwards, these are questions that will need working, right? So these are the real math questions where you're demonstrating you actually understand how to do mathematics and not just very quickly doing that and then picking a multiple choice answer. So this is a question about water. It's about flow rates, in fact, but very simple flow rates. So we're told there are two tanks on a property, tank A and tank B. Initially, tank A holds 1,000 litres of water and tank B is empty. Tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water in tank A is modelled by volume is 1,000 minus 20 times T. So they've told us the volume of water in tank A, so we'll say A dot dot volume is equal to 1,000 minus 20 times time. And this is where volume is in litres and T is in minutes. So they say on the grid, draw the graph of this model. This is essentially just drawing a straight line. So I'll just do this over here on my screen. If we have something like this, the axis down the bottom goes to 55. This is T in terms of minutes. The axis on the side goes up to 1100. This is velocity. This is volume. V, volume in litres. So this is time in minutes. Min. And this is volume in litres. So this equation is what we're graphing. Well, the slope is 20 because this is of the form y equals mx plus b. Now, in fact, the slope is minus 20. This is 1,000 it's a slightly rearranged form of y equals mx plus b. Normally the slope and the x are first and the constant is second. Here the constant is first and the slope and the x value are second. This is because the slope is negative. So this is a common notation. You don't need to do it. This could equally be written as minus 20t plus 1,000. Absolutely perfectly correct. So slope minus 20 and the y-intercept is 1,000. So this is a decreasing line. It's a straight line that goes down. Starts at 1,000. So this is 1,000. It'll then go down. Now, because the slope is minus 20, that means for every unit of time across, you're going to be going down by 20 units. So if we think about some arbitrary time here, let's imagine we pick 20. At the point where 20 minutes have passed, the tank will have lost 20 times 20 many litres. So that will be 1,000 minus 400, that'll be 600. So at this point, it'll be down to 600. So we know it passes through this point, we know it passes through this point, and then we're just connecting the dots. Now, on the grid provided in the exam, if you're drawing this on the grid, it will be much easier. Right? I can't write on the grid paper, but in my little notes section here, the line is a little skewed because I've picked the arbitrary scale. I've picked the scale of my x and y axis, but on the grid paper, this is exactly what you do. You just need to find 2 points the line passes through, get your ruler, get the back of a pen, whatever, and then draw the line down through it, and that will work. Doesn't matter what points you picked. I picked 20 in order to find 600, but you could have picked pretty much any other point, and you would have got the same line. So this, or something along these lines, is going to be your first mark. So this is just worth 1 mark. Very, very straightforward, linear graphing. Nothing overly difficult here. Now for part B, so this is our part A. For part B, we are told tank B remains empty until t equals 15 when water is added to it at a constant rate of 30 litres per minute. By drawing a line on the grid of the previous page or otherwise, find the value of T when the two tanks contain the same volume of water. So if you're going to do this, you're going to have to find the line that governs the volume of water in tank B. And so I'm going to do this algebraically. The graphing method is easier, but it doesn't matter how you do it. That's why the question says using the grid or otherwise. We can do this algebraically, and the algebra works quite nicely. We know tank A's volume, V, is minus 20 times T plus 1000. Well, for tank B, we need to work out what its volume is. It remains empty until T equals 15, and then water is added at a constant rate of 30 litres per minute. So this means whatever the volume of B is, it must have a slope of 30, because 30 litres are being added per minute, and the slope in this case is the number of litres added or subtracted from the tank. So we know that this is 30, and we know it's going to be multiplied by time. What we don't know here is we don't know the B coefficient. So we have this plus B. Now we can find this because we know at the point where T is 15 that the tank is empty. So we know that V equals 0 happens when T is 15. This will let us find B. So we'll get 0 is 30 times 15 plus B. Now 30 times 15, 10 times 15 is 150, 3 lots of that is 450. B must be the negative of that, so B is minus 450. So we get the volume equation for B is V is 30T minus 450. So we have equation 1 governing the volume of tank A, equation 2 governing the volume of tank B. So now, to find the value to find the time at which they have the same volume of water, we're just going to solve these simultaneously. And you can solve these however you want. I'm going to let minus 20t plus 1000 equal to 30t minus 450, but you don't have to use this method of simultaneous equations. You can do any method that gets you an answer. So here we have minus 20t plus 1000 is equal to 30t minus 450. Add 450 to both sides. Add 20t to both sides. We can do these two steps together. Or you could do two separate lines. It doesn't really matter. So this clears this away. This gives us 450 is equal to 50t. So now we're going to divide both sides by 50. So we have 450 divided by 50. This will give us 29. So this implies T equals 29. This is the number of minutes after which the two tanks will have the same volume. Now, in terms of marking, you'll get 1 mark for your working. The working should be relevant to this question. Setting these up as simultaneous equations and solving the simultaneous equations looks difficult here when you could just use the graph, and that's maybe somewhat true. But sometimes you'll get questions like these where you have to set them up as equations. Sometimes the graphical methods may not give you exact values. So in this case, you can use the graph and you can just draw the other line, or you can solve them simultaneously. I like algebra, so I've solved them simultaneously. So this is our working mark. T equals 29 is going to be our answer mark. Now this question has a third part, which is part C. Using the graphs drawn or otherwise, find the values of T such that T has to be greater than 0 when the total volume of water in the two tanks is 1000 litres. Okay, so we know the volume in tank A is minus 20t. So we'll write this as volume is minus 20t plus 1000. And then we know the volume in tank B is 30t minus 450. Now notice the question says find the value of T when the total volume of water in the two tanks is 1000 litres. Now the wording innately suggests that there is one value. There could be multiple values, but the wording suggests that there's only going to be one case. It is not when T is 0, incidentally. A lot of students will say, oh, when T is 0, the first tank is 1000 litres. They have told us the condition is that T has to be greater than 0. So T is 0 is not the value thereafter in this case. What this means is the sum of these two volumes has to be equal to 1,000. So we're going to add these two volumes together. We're going to get minus 20t plus 1,000 plus 30t minus 450 has to be equal to 1,000. This has to be true for the volumes contained within both of them to be equal to 1,000. It has to be true that their individual volume equations sum to 1,000. So now we can just solve this. Minus 20t plus 30t is 10t. So this is just like terms. Plus 1,000 minus 450 is plus 550. This is equal to 1,000 minus 550 from both sides. This gives us 10t equals 450. Divide both sides by 10. And this gives us the t has to be 45. Now this is of course in minutes. This is the time at which the sum of volumes in the two tanks is going to be 1,000. Of course, it is also true that at t equals 0, the sum of volumes in the tanks is 1,000 because one of them has 1,000 litres and the other one is empty. But the question specified for us the value of t where t is greater than 0. So this is the correct solution that we want here. You will get 1 mark for a correct answer that has some kind of either correct working, or if you've used the graphs, just good graphs that clearly demonstrate this.